200 kilonewton stress, normal stress in this plane. 100 kilonewton in the perpendicular plane. And the shear stress is 75 kilonewton. Now we have to find maximum and minimum shear stress in any plane maximum shear stress and the angle of maximum normal stress with current planes. So graphically we can represent in this way. This is normal stress direction, this is shear stress direction. Now for this point 200 kilonewton and 75 kilonewton, that is sigma 200 and tau 75, the this is the point, this is 275, and similarly for this plane there will be another point, that is 100 minus 75. So making this line as a diameter, we can draw a circle. And this circle is Mohr circle. And what is the purpose of drawing this type of circle? That we can get all relevant data, all relevant information through this circle with minimum effort. So we know what is the O. Coordinate of O is 200 plus A is 200 B is 100, then O is middle of that, so this is 200 by 100 by 2, 0 into 150, 0. What is OA? OA is 200 minus 150 equal to 50. What is AC? AC equal to 75. Then we can get the radius easily. It is almost equal to 90 kilonewton. If OC equal to 90 kilonewton, then OF will be 90 kilonewton. So this point denotes maximum normal stress on any plane for this element. So maximum normal stress on any plane will be coordinate of O plus OF. Similarly, this G point shows the minimum normal stress on any plane for this element. Now what will be the maximum shear stress? Maximum shear stress is the radius of this circle. That is equal to this, because this is the maximum shear stress. (90 kilonewton). Now one interesting thing to note, that as we change the plane by 90 degree, here to here 90 degree, here to here 90 degree, we change the plane of orientation of plane. In Mohr circle, this circle, the angle of rotation becomes 180 degree from here to here. That is double of that. So whatever angle we are getting in Mohr circle will be half in the original element. So let us see how does it work. We have to calculate the angle theta. Tan theta is equal to AC by OA, that is 75 by 50 equal to 3 by 2. So then what is theta? 3 by 2 is equal to 1.5, shift tan inverse equal to 56 degree. So theta is 56 degree. So here the maximum normal stress plane is 56 degree angle away from the plane shown in the problem element. So in the original element, it will be at angle of phi equal to theta by 2 is equal to 28 degree. With which plane? With this plane. On which plane? On this plane, 200 kilonewton normal stress is working. and this is the 200 kilonewton point. So from here, anti-clockwise, theta is moving. So here, if we rotate it anti-clockwise, we get, this is the plane. That is, here it will be 28 degree, for which on this plane we will get the maximum normal stress. And minimum normal stress will orient at an angle 90 degree with this plane. So we get the planes at which the maximum normal stress and minimum normal stress works. Now there is a concept by which we can visualize the orientation of the plane for any stress. There is a concept called pole. So how, on this circle there is a point that we can call pole. How we can get the pole? So this point 275, we will draw a horizontal, we will draw a line parallel to the plane on which this stress works. So this is the horizontal plane on which this 200,75 works. So parallel to this horizontal plane, we will draw a horizontal line. Similarly, this 100 minus 75 works on vertical plane. So we will draw a vertical line here, and they will meet at this point P, and we can call this point pole. Now if we draw a line in this way, it will be exactly be 28 degree. And if we draw this line, it will be exactly this 28 degree. That means by using our old geometry, we can get all the information necessary. And for the maximum shear stress plane, we will get this plane, and this plane. So we are getting all the relevant answers for our problem, and this is all what we know about Mohr's circle.